Okay, y'all, today is January 24th, and we are working on solving two-step equation word problems. So this is your extra practice that's in your notes packet. So grab that piece of paper, a pencil, a calculator, and let's get started. Let's start right here with number 1. Mrs. Rowland distributed a bag of Skittles to her students. She gave each student 5 Skittles and then the 8 that remained in the bag. If there were originally 143 Skittles in the bag, how many students does she have? Okay, so we're trying to answer this question here. How many students does she have? So it doesn't matter what variable you use, but X is a very common variable, so I'm going to use X. So I'm going to let X represent the number of students. Okay, now let's identify some important pieces of information. So we know that she gave each student 5 Skittles, so that's important. She ate the 8 that remained. Kind of funny, she ate the 8. Okay, and we know that there were originally 143 Skittles in the bag. Of those 3 numbers, is one of those a total? Hopefully you identified that 143 is the total. So you know I like to write that is the total. And I like to identify that because I know where it goes in my equation. I know the total goes after my equal sign. So in this equation box, I'm going to go ahead and write equals 143. Okay, that means we just have to figure out what goes on this side over here. And I know I'm going to use a 5 and I'm going to use an 8. So I've got to ask myself, of the 5 and 8, which of those numbers should my X be attached to? Well, we know that she gave each student 5 Skittles. So each is a key word. Each means that I'm going to attach my variable to that 5. So I know I'm going to have 5X, and I'm also going to have an 8. Now, what operation should connect those two pieces? Well, she gave each student 5 Skittles. So this represents the total number of Skittles that she distributed. Then she had this many left over, and altogether when I combine that, I get 143. So I'm going to combine it by adding. Now you should look at that equation and think, I know how to solve that. So let's go ahead and do that over here. So we have 5X plus 8 equals 143. I'm going to use some teacher magic and move that over just a little bit. Okay. First, I'm going to draw my line down my equal sign. That helps me see that whatever I do on one side, I must do on the other. Now I'm trying to get the X by itself, and I have to work my way away from the X and close towards the X. So I'm going to start by subtracting 8 on both sides. So my 8's will cancel out, and I'm left with 5X over here on the left, and 5X equals 135. Now to get X by itself, I'm going to divide by 5, and I do that on both sides. So my 5's cancel out. X is by itself, and when I take 135 and divide by 5, I get 27. 27 what? 27 students. So in the solution box, I'm going to write 27 students because that is my answer. Okay, let's move on to number 2. Sarah bought a binder for $7.25 and 6 folders that totaled $9.05. How much did each folder cost? Okay, we're trying to answer this question right here. It doesn't matter what variable we use, but a common variable is X, so that's what I'm going to go with. So X represents the price of a folder. Okay, how much the folder cost? Well, what is some important information that I might circle? She bought a binder, and the binder cost $7.25. She bought 6 folders, and the total amount that she spent was $9.05. Okay, well, I just pointed out that the total she spent was $9.05. So I know where the $9.05 needs to go in my equation. It goes after the equal sign. I'm going to write it as 9.05. So I've just got to figure out what goes over here. Okay, I know I'm going to have 7.25 and I'm going to have a 6. Which of those two numbers is attached to my variable X? Well, she bought 6 folders, and they each cost the same amount. If I think about it that way, I know then that my 6 has to be attached to the X. So we're going to have 6X, oops, 6x, and we know the binder costs $7.25. So what operation connects those two pieces? Well, hopefully you said addition, because whatever she spends on the folders plus what she spent on the binder should equal her total $9.05. Now, that is an equation you know how to solve. So we're going to go ahead and rewrite it and solve it over here. 6x plus $7.25 equals $9.05. I'm going to go ahead and draw my line down my equal sign to help me see that whatever I do on one side, I must do on the other. Now, to get x by itself, I'm going to work my way away from the x, in close towards the x. So I'm going to start by subtracting 7.25 on both sides. So on the side with the x, 7.25 cancels out. 6x is by itself, so I'm going to bring that down. Now on the other side, I have $9.05 minus $7.25. And when I subtract, I get $1.80. Now to get x by itself, I'm going to divide by 6. And I do that on both sides. So x equals, and if I put this into my calculator, 1.80 divided by 6, I get 0.3. Because we're talking about money, I'm going to add that extra 0, because that tells me that each folder costs 30 cents. So my solution is 30 cents per folder. Okay, moving on to number 3. Evan used half of his paycheck for his car payment, then $125 for groceries. If he has $215 left, how much was his paycheck? So I'm trying to answer this question right here. How much was his paycheck? So it doesn't matter what variable we use, but I'm going to use x because it's common. So x represents the paycheck amount, right? Okay. What is some other important information I might circle? Well, I'm going to go with half because he used half of his paycheck. Then he had $125 for groceries, and he had $215 left. Okay, so of those 3 numbers, is one of them a total? Well, he used half of his paycheck, and then he used $125, and he has $215 left. $215 is our total. So because that's our total, we know where it goes in our equation. It goes after our equal sign. So I'm going to go ahead and write equals 215 down here. So I'm just trying to figure out what goes on the other side. Okay, well, I've got half and 125. Okay, so can we agree that he's taking his whole paycheck and using it for certain things? I think we can agree on that. And he's starting with half of his paycheck that he's using for his car payment. So how do I represent half of his paycheck? Well, there's a couple different ways I could do that. Remember, half could be 0.5, it could be 1/2, or it could be x over 2, where x represents his paycheck. So it doesn't matter which one you do. I'm going to go with 1/2, and then I'm going to attach the x to that. So 1/2 x. Now he's also using $125 for groceries. The 125 also goes over here. But what operation connects these two pieces? Well, because he's using that money for groceries, we're going to subtract. So 1/2 x minus 125 equals 215. That's an equation that you do know how to solve. So we have 1/2 x minus 125 equals 215. I'm going to start by drawing my line through my equal sign. And the first thing I want to do to get the x by itself is to add 125 on both sides. So when I do that, on the side with the x, the 125 cancels out. That leaves me with 1/2 x by itself, and that equals 215 plus 125 is 340. Now to get the x by itself, I could divide by 1/2, but eventually I'm going to have to do keep, change, flip. So I'm going to go ahead and do the change, flip part. That means I'm going to multiply by the reciprocal, and the reciprocal of 1/2 is 2 over 1, or just 2. So I'm multiplying by 2 on both sides. So on the side with the x, everything cancels out, leaving x by itself. On the other side, I have 340 times 2, which is 680. So x equals 680. 680 what? $680. Okay, let's move on to number 5. Kate's math homework had a set of equations and one word problem. She took 3 minutes to solve each equation, then 7 minutes to solve the word problem. If it took her 52 minutes total, how many equations did she solve? Okay, we're trying to answer this question here. So it doesn't matter what variable you use. I'm going to use x because it's super common. So x equals the number of equations. Okay, so some important information here. 3 minutes to solve each equation, then 7 minutes to solve the word problem, and 52 minutes total. Okay, well, it tells us the total. The total is 52, and I know that that goes after my equal sign, so I'm going to say equals 52. Okay, so that means I'm going to need a 3 and a 7 and a variable to go over here. So 3 or 7, which one of those should be attached to my variable? Well, if you read it carefully, she took 3 minutes to solve each equation. So that means that 3 needs to be attached to my variable. So I'm going to have 3x, but she also spent 7 minutes to solve the word problem. And altogether, when I combine that, I get 52 minutes. So I need to add these two together. So that's an equation that you know how to solve. So we have 3x plus 7 equals 52. I'm going to start by drawing my line through my equal sign. And my first step to get the x by itself is to subtract 7 on both sides. So on the side with the variable, the 7's cancel out, and I'm left with 3x that I bring down. On the other side, I have 52 minus 7, which is 45. Now to get x by itself, I need to divide by 3, and I do that on both sides. So my 3's cancel out, x is by itself, and x equals 15. Well, 15 what? 15 equations, right? So 15 equations is our answer. Okay, let's do one more, and let's do number 7 right here. So Evan bought a bag of Skittles, ate 13 of them, then distributed them evenly into 4 bowls. If there are 64 Skittles in each bowl, how many were originally in the bag? Okay, so we're trying to answer this question here. So let's first define our variable. So our variable needs to represent the number of Skittles in the bag, right? The original amount of Skittles. So x equals the original number of Skittles. Okay, some important information here. He ate 13 of them, and then he distributed them evenly into 4 bowls. There are 64 Skittles in each bowl. Okay, so that's all of our important information. Is one of those numbers a total? Well, hopefully you were able to identify that 64 is the total. That's the total amount in each bowl. So I know where that goes in my equation. It goes after my equal sign. So equals 64. So that means I just have to figure out what goes over here. And I'm going to have a variable, 13, and 4. Well, let's think about this situation. So first he buys a bag of Skittles. It has X amount of Skittles in it. Then he eats 13. So how do I represent that he eats 13? Well, hopefully you said subtraction. Now he takes that whole amount, the starting amount minus the 13 that he ate, and he distributes it evenly into 4 bowls. What operation distributes evenly? Hopefully you're saying division, because that means I'm going to divide. So x minus 13, I take that whole amount and I divide it by 4. So my equation looks like this. X minus 13 divided by 4 equals 64. Now that is an equation that you know how to solve. So let's rewrite it over here and solve it. So x minus 13, all divided by 4 equals 64. Now I'm going to draw my line down my equal sign first. Okay, the first thing I want to undo is that dividing by 4. So how do I undo that? Well, I multiply by 4. So I'm going to multiply by 4 on both sides. So on the side with the x, my 4's cancel out, and I'm left with x minus 13. And on the other side, I have 64 times 4, which when I multiply that together, I get 256. Now to get x by itself, I need to add 13 to both sides. So my 13's cancel out. X equals, when I add that together, I get 269. Well, 269 what? 269 Skittles. And that is the end of our little mini lesson on two-step equation word problems.